Hello friends, welcome to Engineering Chemistry. In this video we will learn cracking of petroleum. Cracking of petroleum is defined as a decomposition of bigger hydrocarbon molecules having a higher molecular weight, or we can say that it is a high boiling point fraction, into a smaller hydrocarbons having a low molecular weight or into a low boiling point fraction. For example, if I have a decane having a formula C10H22, its boiling point is 174 degrees Celsius. When it is subjected to cracking, it gets converted into two molecules, pentane and pentene. Both of them they have a low boiling point around 36 degrees Celsius. This conversion of decane into pentane and pentene is called as cracking of petroleum. That is a conversion of higher boiling point fraction into lower boiling point fraction. The process of cracking is carried out for the production of gasoline or petrol, because the demand of gasoline or petrol is very high and that much gasoline is not available, so it can be produced by cracking of higher hydrocarbons. This cracking is of two types. One is thermal cracking and the second is catalytic cracking. Let's move to thermal cracking. In thermal cracking, the heavy oils are subjected to high temperature and pressure when the bigger hydrocarbon molecules break down to give smaller molecules of the paraffins, olefins plus some hydrogen. This is also of two types. First is liquid phase thermal cracking and the second is vapor phase thermal cracking. In liquid phase thermal cracking, the heavy oil or gas is cracked at a suitable temperature at around 475 to 530 degrees Celsius and under pressure of 100 kg per centimeter square. The yield of thermal cracking is around 50 to 60% and octane rating is around 65 to 70, which is very less. In vapor phase thermal cracking, the pressure is lowered at around 10 to 20 kg per centimeter square. When the pressure is lowered, all the liquid gets converted into a vapor, and the same process is carried out at around 600 to 650 degrees Celsius. Here the yield is around 50 to 60%, but the petrol obtained has a better anti-knocking properties but poor stability than the liquid phase cracking. As we can see that the pressure and temperature applied in both the cases is very high and it is very difficult to achieve that high temperature, high pressure. Also, more fuel is required to achieve that high temperature and pressure. In order to avoid this, in 1940s, the same process is carried out in the presence of catalyst. This process is called as catalytic cracking. This is also of two types. First is fixed bed catalytic cracking and the second is fluid bed catalytic cracking. Let's see what is the catalyst that is used in the process. Modern cracking uses zeolites as the catalyst. These are complex aluminosilicates and are large lattices of aluminium, silicon and oxygen atoms carrying a negative charge. They are associated with positive ions such as sodium ions. Sometimes alumina is also used as a catalyst in the process. In this process, first there is a preheater, then second there is a catalyst chamber which consists of fixed beds of catalyst one above the other. Here the catalyst is in the form of fine granules and there are fixed beds, therefore the name is given as fixed bed catalytic cracking. Then there is a fractionating column which separates the gasoline into three layers: upper layer, middle layer and lower layer. Generally a middle layer is the layer which contains pure gasoline. After this there is a cooler to condense the gasoline. At the end the gasoline is collected and from this gases are removed from the stabilizer. First the heavy oil is charged into a preheater where the heavy oil is heated at a temperature of 425 to 450 degrees Celsius. Here almost all the heavy oil gets converted into a vapor phase. These vapors are then sent to a catalyst chamber. When these vapors are passed into a catalytic chamber, the process of cracking occurs. For example, decane gets converted into pentane and pentene. The cracked vapors then pass into a fractionating column where different layers of gasoline are collected into the different layers of fractionating column. Once this fractionating columns separates the upper layer, middle layer and lower layer, the suitable layer of gasoline is then sent to a cooler where it gets condensed into a liquid gasoline. This gasoline still contains some dissolved gases, Hence it is sent to a stabilizer where it is heated at a suitable temperature. The gases are removed from the top and pure gasoline is collected at the bottom. The octane number of this gasoline is around 80 to 85. After some time, the catalyst gets exhausted, that is, the whole surface area of the catalyst gets blocked. Hence, it has to be regenerated. So, the catalytic chamber is replaced by a fresh catalytic chamber and the old chamber is heated in the presence of oxygen to convert the accumulated carbon on the surface of the catalyst into a CO2 gas. This CO2 gas is evaporated and the catalytic chamber is regenerated. So that is how there are two catalytic chambers which are used alternatively, which is very time consuming. Hence it was replaced by fluid bed catalytic cracking. Before we move to the fluid bed catalytic cracking, let's see what are the advantages of catalytic cracking. First is the yield of petrol is higher. Isomerization to branch chain compounds occurs, thereby better quality of petrol is produced. The heat required for the cracking is derived from the coal embedded in the catalyst, hence no external fuel supply is required. A much lower pressure at around 1 to 5 kg per centimeter square is needed for catalytic cracking. The cracking process can easily be controlled to get the desired products. For example, instead of gasoline, we can get some other products which are obtained by the cracking process. The product of cracking contains a high amount of aromatics and hence the petrol possesses better anti-knocking characteristics. The product contains a very little amount of undesirable sulfur because we know that sulfur on reaction with hydrogen, which is already there in the hydrocarbon, it produces H2S gas which is harmful for the environment. This formation of H2S gas is minimized. Catalysts are selective in their action and therefore they permit cracking of only the high boiling point hydrocarbons. Let's move to the fluid bed catalytic cracking. In fluid bed catalytic cracking also there is a preheater, then a reactor, there is a catalyst regenerator, cyclones for the removal of gases, then there is a fractionating column, a cooler and a stabilizer. We have seen that in case of fixed bed catalytic cracking, the problem was the catalytic chamber gets exhausted and it has to be replaced by another catalytic chamber. So that was a time consuming process. The fluid bed catalytic cracking is a continuous process. In this process, the feed oil is charged into a preheater which is maintained at around 425 to 450 degrees Celsius. At this very high temperature, all the heavy oil gets converted into a vapor and now this heated oil is mixed with the catalyst from the catalyst regenerator. This heated oil is mixed with the catalyst and this mixture of catalyst and oil is sent to a reactor where it is heated at around 500 degrees Celsius to convert it into a vapors. The spent catalyst is removed from the bottom and with the help of a blower, this spent catalyst is pushed into a catalyst regenerator. Here the exhausted catalyst is heated at around 600 degrees Celsius where the catalyst regeneration process is carried out. The carbon is converted into CO2 and removed as a flue gases from the top. The regenerated catalyst is again gets mixed with the heavy oil and thereby it is a continuous process. The cracked vapors are then pushed into a fractionating column to get different fractions of gasoline. In fractionating column, the heavy oil is removed from the bottom whereas the lighter fraction is removed from the top. This lighter fraction is in the form of vapors. It is sent to a cooler to get condensed into a liquid form. If any gases are still present in the cooler, then they are removed from the top whereas the mixture of gas and gasoline is sent to a stabilizer. In stabilizer, this mixture is heated at certain temperature and pure gasoline is collected from the bottom having an octane number at around 85 to 90. If there are any gases, these are removed from the top. So this is the whole fluid bed catalytic cracking process. The advantage of fluid bed catalytic cracking is it is a continuous process and it saves the time. If you like my video, click on like, do share and subscribe my channel. If you have any comments, do mention it in the comment box. Don't forget to press the bell icon to get the notification of my new videos and keep watching Engineering Chemistry. Thank you.